All right, hello again. And what we're going to really talk about now, and I just kind of a recap of where we've been at, is we are looking at data we have measured. So we've come up with some experiment and we get data, something we have measured, usually on a variable of interest. So right now we're looking at one variable of interest. Which we've been calling X. And so there's some collection of data points, each data entry from all the things we measured. And there are n pieces of data in our collection of data. And what we've been able to do is if we look at the entire data set, if it's a population, we'll say the total number of pieces of data are n, so I'll put populations over here. And if it's a sample, we'll write little n. And this is kind of our notation to distinguish how many pieces of data there are. And then we can talk about, or we can describe this set of data with the mean. And those will be the two symbols we use for the mean, which is a average or a middle for the data. It's one way of describing the middle. And we had some other things we could look at to talk about our middle. And so I'll make a section of things for middles here. We had the median and the mode. And sometimes modes. There are points in the data that might be multiply repeated. With the mode, we're looking for the most repeated data point. And these all describe the middle in some way. The median, the point where the median is at, 50% of your data entries are before it and 50% are after. And the mode is the most repeated. And what we started to notice with distributions, I'm again going to start using this bell-shaped curve. One that we like a lot has a mean that's equal to the median, which is equal to the mode. And we can say mode because the most stuff is in this central column, 50% of it is here, and 50% of it is over here. And so these are ways we started to measure our data, and specifically our middle of the data. But I could have the exact same mean, median, and mode, and I could have a narrow distribution, but it still has the same median and mode. So we had to talk about how the data varied, how wide the data was. And that was our discussion on variance. And so the other thing we could talk about is the variance, which for a population is sigma squared, and for a sample is s squared. And that's our variance. And the variance talks about the standard deviation, which is sigma and s. And that's the standard deviation. And if we wanted to compare, we could look at coefficients of variation, which was sigma over, sigma over the mean, or s over x bar, depending on if we're looking at a sample. And it's a way of comparing data sets because it was unitless. And this is kind of the numbers we've attached to our overall data set. We're talking about how all the data looks. What we want to work on now is position. And in position, we will start talking about how individual pieces of data or collection of data fall in position. So again, going back to that standard deviation curve, and our empirical rule gave us some boundaries we could think about. And the empirical rule said there was 68% of the stuff within one standard deviation on either side. And we know there's 50% before and 50% after the mean. And so notice I'm talking about percentage-wise where data is. So I could look at one piece of data, one value, I could say, well, more than 50% of my data comes before that. And we're going to look at ways of describing the position of individual pieces of data or clumps of data. And what we do is we will break our data into fractional parts. And so we have things called fractiles, which are the number of partitions ordered sets of data are divided into. And notice we want to do this in order. For this to work, my lower pieces of data, the x-mins have to be here, and my x-max have to be over here, and everything in the middle is in order, because the order is going to tell you where you fall related to the overall data distribution. And I think the most common way we do this is what's called quartiles. And we break it into means, or not means, medians. And we break it into four medians, four parts. And so if this is x-min, and this is x-max, we find the median, and then we find the median here, which is this quartile 1, and the median here, which is quartile 2. We now have four equal parts that have divided our data with 25% here, 25% here, 25% here, and 25% here. And so there's equal amounts of data, not value, but amounts of data in the quartiles, and they each take up a quarter. And so we tend to name them, as this is the first quartile. It's everything from the 0 point up to and including the first quartile. We get the second quartile, which is everything up to and including the median. And then, whoops, that should be quartile 3 up here. And then the third quartile, everything up to and including the third quartile. And then, we don't really call it the fourth quartile, it's all of our data. And so everything up to this is 25% of the data. Everything up to here is 50% of the data. Everything up to here is 75% of the data. And everything up to here is 100% of the data. And that's what quartiles do for us. They set up, where our data comes in order and how much stuff is there. And in a way, we can actually create really quick visual and organized understandings of the data with quartiles. So for example, again, using the example in the book, each year U.S. automobile commuters waste fuel due to traffic congestion. 15 largest cities, we're looking at the gallons of fuel wasted per year in traffic congestion. And so the data set in gallons of oil, let me write it down here. Now again, if I was doing this job-wise, I would put all of this into Excel, and I would have Excel order the data for me, but we're going to order it by hand. And so I think when I was writing through, I noticed that was my x-min. I'll even keep a mark over that here. X-min is 11. I think my x-max was, it's in the 30s, I think, 35. There should be two 35s in there. Did I miss one? Let's see, 35 right after 20. No, there's another 35 back here. And so X max is 35. And so I'm going to put this data in order. So the first piece of data is 11. My next piece of data is this 20. Then 22. Then 23. 24. And 25. I have 1, 2, 3 25s. And let's see. There's 28 over here. Any more 28s? I don't see any more 28s. 29. And 29 again. 30. 33. And then there's two 35s I pointed out when I started. So there's my data in order. Ordered data. So the first thing I'm going to do, I'm going to find the median. And so I need 50% of my data in front of it and 50% of my data behind it. So there's 15 pieces of data. So that means I can put 7 in front and 7 behind, and I'll have a number in the middle, right? Or what I do is I count 1 on this side, 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 1 on this side. And that is my median, which defines quartile 2. Okay. And then now what I want to do is I want to find the median of the two sides of it. And so there's 1, 2, 3, 4, 5, 6, 7. So 1 on this side, 1 on this side, 1 on this side, 1 on this side, 1 on this side. And that, 23. Okay, did I miss one here? 25. I'm on the wrong 25. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I got that right. I'm getting slightly different than the book. 2 25s. 1, 2, 3, 4, 5, 6, 7. Good. 1, 2, 3, 4, 5, 6, 7. Did I mess up a data entry? 11, 20, 22, 23, 24, 25, 25, 25, 28, 29, 29, 30, 33, 35, 35. No, I'm okay. Maybe the book made a mistake here. 1, 20, 22, 23, 24, 25, 25, 25, 28, 29, 29, 30, 33, 35, 35. 2, 4, 6, 7. 2, 4, 6, 7. I have, well, yeah, the book actually made a mistake in the example there. Interesting. Never noticed that before. So this would be quarter 2. And this would be quartile 1. And then I want to divide this into half. So I take 1 from that side, 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 and that is quartile 3. And so I have equal amounts of stuff in each bin. And everything on this side of it is quarter 2, and everything on this side of this is quartile 1. Oh no, okay, I see, I'm doing the same thing as the book. They're doing from the line over. And I'm circling the one that makes the border or the boundary. But this is how we make quartiles. And notice there's something we can do with this if we put the quartiles into a plot. And what we want to do is we want to find kind of the distribution and shape. So we can talk about the interquartile range which is the inner quartile from Q1 to Q3. And so we take Q3 minus Q1, so 30 minus 23, and that's 7. So there's 7 pieces there's 7 of value in there. Well, let's plot this and see what happens. So I start with my min at 11. Then I'm going to count in ones. So let me draw a number line here. And my max is over here at 35. And so I want to break these into even counts. I might have to do a little erasing here. So I'm going to go 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 7, 8, 9, 30, 31, 32, 33, 34, 35. I'll make a 35 out here. Sorry about that. Erase that point. Erase 35 over here. I'll put it all the way on the end there. And so now I have my data branched out, but I want to actually focus on the quartile. So I'll come to 23. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There's 23. And so my first quartile is this long exchange up to here. But then my next quartile goes to 30. 23, 24, 25, 26, 27, 28, 29, 30. 30. And so quartile 2 lies within this box here, and quartile 3 is here. Well, each one of these quartiles is 25%. And so we make something called a box and whisker plot, where I box quartile 2. And quartile 1. So I take this inner quartile range from quartile 3 all the way to quartile 1, and 50% of my data is in there, 25% there, and 25% there. And those becomes the whiskers on the box. And so this gets a box saying, hey, most of your data, 50% of your data is in here. And we can already see kind of a distribution coming about from this. It's a really quick distribution telling you where most of your data is centered. And so what we've developed slowly is a way of talking about our data using what can be a summary of the data. And so right at the end here, we have our range of data, which is the max minus the min. That tells us how expansive our data is. We have our interquartile range, which is Q3 minus Q1, which tells us how expansive or how tight or how close together the middle 50% is. The middle, because middle is one of the things we want for. And then we can kind of bounce this around with the median, which tells us where the middle 50% is. And this all comes together in what's called a 5-number summary, where you want X-min, quartile 1, the median, which is quartile 2, quartile 3, and the max. And knowing these four numbers, you can get a feel for where your data is, how bunched up your data is, and how close together your data is falling. Now, quartiles are common and quick to do, but we have other types of numerical ways of doing these. In fact, we like using percentiles, where we divide the data into 100 parts, and we talk about the 99th percent, the 100%, and so on. And you'll find as we move along, we'll talk a lot about percentiles and quartiles, because they become the easiest in our language to use.